All right. So, welcome to this monthly Grafana Community Call on the 25th of April, 2024. We have a couple of items on the agenda. We'll go through them as usual and then, open the floor for questions. So let's get to it. The agenda is linked into the meeting invite as a doc. Okay, so the first thing that we want to cover is a question that came up on the last community call about. Yep. Oh yeah, thank you, Dimitar. Right. So the first thing that we want to cover is that something that came up on the previous community call, which was a question of what to contribute to and how to contribute. And basically, there are four main areas of issues. One is the actual Mimir Golang code, where you can find some issues marked with a good first issue label in GitHub. That is a pretty good place to start, or you can start in any place really. Then there are the mixins. These are written in JSON.NET, and these are used to generate the dashboards and the alerts and recording rules that we publish with Mimir. You can use this to monitor your system and get started on that. And the last area is the deployment tooling, so kind of packaging. And there we have, again, JSON.NET and Helm. Helm is, according to our measurements, Helm is the most widely used. So that's actually a good place to contribute. But other than that, so that's, I guess super generic, but more importantly, basically we advise anyone to just contribute to what they have a problem with or they want to improve. And so we can start helping you on those PRs, basically. So we don't really want to dictate like you should do this or that, but please feel free to contribute on things that concern you. I don't know, Dimitar, if you want to add anything. I know you.
Not really. I think the most important part is to do stuff which is relevant to you, which would help your org and how you use Mimir. Obviously, we're open to contributions just for the sake of contributions, but if it helps, it's better. You already said that, yeah.
Yeah. And then about how to contribute, we do have like documentation on how to contribute, like what things to consider. This includes the Go code as well as the Helm chart. So the Helm stuff has its separate how to contribute documentation. But feel free to open a PR with a proposal at any time. And if you're not sure if it fits into Mimir, open an issue with the problem and your proposal for discussion. I would also say that as a bit of an expansion on this is that a lot of times we see that PRs get a little bit stuck on formalities, like changelog and updating unit tests that are getting affected. So I hope that, like, we are thinking of making those things easier, but unfortunately at this time these are kind of required because even this code that we are working on, you have to know that it gets into Grafana Cloud. So what you get as a service from grafana.com, that pretty much runs this. So if you are running, open source Mimir, you're running almost the same thing that runs in production for us. So we have to be, have to keep a tight ship basically, and really can't really relax those requirements. All right. Any questions on this part? Actually, I'll stop here for a second. If no, then okay, about the helm 6.0. So I just wanted to bring this up because the last major release of helm was a year ago. I think it was last July for Mimir, and we have discussed a little bit the next major release at a meeting that we had, a team meeting, and yeah, the scope is kind of shaping up. I would expect that we will have a major release, maybe alongside the next Mimir release or the one after that. And the one thing that is kind of new, or at least was new to me, that we had community contribution into the Helm charts repository that we have, and now a bunch of Grafana Helm charts are being released into the OCI repositories as well. And we're unsure, like, we haven't implemented this for Mimir yet, but that might be something that we will do. I don't know if the people present on this call have any preference, if they actually heard about OCI repositories, or if that's, you know, something completely new to you.
I saw quite a few thumbs up on the issue in Helm charts. So
Yeah,
I think it's popular.
Yeah, I think so. Yeah, I think a little bit of the issue is that we have the legacy way documented as well in every place. So it takes some work to actually get this working and document it and have everybody on board for it. Anyway, this might be coming in 6.0. But what I can for sure say is that we will not stop and remove the old legacy way of doing things for a while. So it shouldn't affect everybody like negatively. All right. So next topic is that we started working on migrating Mimir to use native histograms for latency metrics. This is progressing very slowly, but this would mean that when you install Mimir, you would be able to see much better resolution latency histograms, latency information about your about the request being handled by Mimir, and also this will bring in updates to the dashboards and alerts and recording rules. But again, this doesn't mean that the old, like, you don't have to change to native histograms, but this would be an improvement in many cases. All right. Let me hand over the reins to Dimitar actually to talk about a very interesting topic, I think.
Great. I'm going to talk about depth congestion. So internally, well, I mean, not internally, but the Grafana Labs, me, Marco, Peter, Vladimir, Jonathan, and Nick have been working, quite a few people, working on ingestion via Kafka. So the gist of this architecture is that we're introducing Kafka in between the ingesters and the distributors. So with this architecture change, the ingester moves to being solely a read path component. The goal, like, there are a few primary goals with this. First is that we decouple the read and the write path. So whenever ingesters have an outage, there's no longer a full outage on the write path as well. It's only queries which are affected. And right now, well, I mean, with Kafka, if Kafka has an outage, then reads are not that affected. Like, you might get slightly stale data because you cannot read from Kafka, but whatever's been consumed from Kafka is available. A second goal is to make multi-AZ deployments a bit more feasible and a bit cheaper. So today, because of how Quorum works, because of how each query needs to access data from 2 ingester zones, the cost of deploying Mimir in multi-AZ cloud environments is quite big. I think some folks have said that networking costs are higher than compute costs. When introducing Kafka, this should reduce, because then what's copied is only the ingestion traffic, and then per zone, queries will only need to access the zone local data in ingesters. And then a final something which comes as a side effect, like was not a primary goal, is to reduce replication factor. So partitioning data changes in this new architecture. Series are sharded to partitions; they're not sharded specifically to ingesters. So this means that we can drop the replication factor from 3 to 2, and then queries only need quorum of 1, don't need quorum of 2. So one query only needs to read from every Kafka partition once, or like every Kafka partition from one ingester who's reading from that Kafka partition, and then the query can succeed. So this hopefully accounts for the cost of Kafka, and maybe even offsets it, or sort of drives further cost further down. But we're still not sure. It's still experimental. And very much a work in progress. We've been merging code into Mimir with pull requests. So if you, I don't think we have a label, but perhaps if you just search for Kafka in PRs, yeah, I'll find 52 open PR, merged PRs. We haven't documented this, so configuration parameters are hidden. The reason is that this is, like, we still weren't 100% sure how to run and configure this. We didn't want folks to get confused by a bunch of configuration parameters. There's also no issue tracking the work, which I think will change soon. We'll have some central place which describes the new architecture and how work has been going and how it's planned. That's about it. So we've been working sort of quietly on this, only through PRs. PRs should have good descriptions, but they're not exactly the way to communicate with the community. So yeah, I decided to put this out in on a community call. I think that's all I have.
I do have one question, which is that. Can you hear me, Dimitar?
Yeah, I hear you now.
Okay, so I do have a question on behalf of everybody that probably wants to use this. Is do we know already? Because I'm not in that project, that's right. So do we know already if we would deploy Kafka from our Helm or JSON.NET, or would that be something that the user would have to do?
I think it's not something we've explicitly discussed. My take is that Helm chart should be sufficient to deploy Mimir, so maybe we'll have some Kafka deployment. I don't know how to deploy Kafka with Helm, so maybe that's too complicated and becomes out of scope. Yeah, Peter?
Well, in our case, we already had Kafkas in our cells where we tested this because of the other product, but there is a Kafka Helm chart, so it's easy to deploy Kafka into your Kubernetes. I wouldn't necessarily bundle Kafka Helm chart with Mimir and just make it a prerequisite if that's something that's possible in Helm world. But Prior, you probably know better.
Yeah, you can bundle, like you can depend on other Helm charts, but they get bundled then. Like that's how we do Minio and Memcached. And if you want to keep the philosophy of the getting started guide that you just need to install this one thing and get started, then we will have to do it. Or do something else, like have something that can replace Kafka, like some in-memory queue or something that is just for the purpose of demoing. But anyway, that's some ways off.
Yeah, we are very far from having home chart for this yet. But it sounds like we should be able to depend on Kafka home chart from what you are saying. So I think that would be the way forward once we get there in a year or two.
Yeah. Andrea?
Yeah. Wouldn't this be just like moving the problem from one part of the architecture to Kafka? I mean, how does it remove the outages on the ingestion path, for example? I mean, if Kafka is down, would be the same as the ingester being down, no?
If Kafka is down, then the ingester cannot receive new data, but it can keep serving whatever it's received so far.
Yeah, but I mean for the write path would be
for the write path. The distributor writes to Kafka, and then the request is done. The distributor doesn't wait for the ingester to receive that. So as long as it's in Kafka, the write request is sort of
I'm saying if Kafka is down, then it will still be down.
If
then
Kafka
your
is
write
down,
path is down. Yes.
the write path is down. Yes.
Yeah, but is that so common that the ingester is down? I mean, wouldn't like the same type of issues that are affecting the ingester now affecting Kafka as well? Because managing a big for small clusters is good, but Kafka for very big cluster is quite challenging sometimes. Well, at least historically, when I work with Kafka in the past, I haven't worked in a few years now, but
in our experience, a lot of the issues with ingesters happen because of queries. So they're usually fine just ingesting, a fairly robust ingesting whatever you throw at them. Whenever complex queries come in, or I don't know, white label values requests, you end up with high CPU, and then this slows down the write path. So we think that you don't just move the problem, you sort of separate two problems, and then the write path should become more resilient. Kafka is also a bit more robust than Mimir. It's been around for longer, more companies investing there. So it should be able to handle more write surges than Mimir. Yeah, it is complicated to run. So we don't have to run Kafka. I think there are Kafka replacements. We only need it would only need the Kafka protocol. I think you can pay cloud providers to run Kafka for you, or there's some Kafka-like implementations. I think we only use very basic protocols, so nothing really complicated.
Okay. And doesn't the I see that in the Mimir there is a config option that basically limit the amount of CPU that is used for the query path. Does that mean that it is doesn't really work well, or?
I think maybe others have more experience with this, but I think it didn't quite work so well for us. It's a bit slow in responding, and I don't quite repeat, Peter.
Well, Arve is on call. We implemented this, but the way it works is it basically stops the query from working. So it will keep alive your write path, but querying will go down if you configure the limit and CPU usage is over the limit. So that's not so great. With this new architecture, ingesters, they are still fetching the data from Kafka, but using only single Go routine. And as long as they are up to date, they will always unless that one single Go routine consumes your entire CPU cores or limit that you give it, which should not be the case, then your queries should be still working.
So, sorry, I didn't understand. Can you say it again? How does that work? So, like, if I limit the CPU to, I don't know, 3 CPUs, how do you make sure that it never goes above that?
You mean in the current code?
Yeah, in the CPU limit. The
So right now, well, Arve can tell us, but if I remember correctly, it's basically checking some /proc files to see what's the CPU usage of the process.
Okay.
And as soon as it goes above the limit, it will basically stop the read path. Is that correct, Arve?
Basically, it does. Yeah, it reads the CPU utilization from the proc file system, and it does weighted moving average. So it's not the raw utilization, but it's an average. And then if it's above the configured threshold, it starts rejecting reads. So that's how it works.
But how do you know that is the process is in the read path?
I mean, the ingester is both a read and write path components.
Yeah,
So
but
this limit only exists on the ingesters.
Yes,
You
exactly.
can only configure it in
the
ingesters.
ingester, let's say that the ingester has 10 cores, and how does the ingester process knows that which, like, if you look the utilization, like, how do you know? Like, so let's say that the GOMAXPROCS is set to 10. The go runtime will spin up 10 OS thread or more if there is someone waiting for IO or something. How do you know which one of those is actually using? So you can see the utilization per.
It's
Only
just,
per full process.
yeah, it's only for the whole process, exactly.
Yeah, but how do you know which? So the all the Go routine in the ingester will be a little bit. You will have I don't know, tens of thousands for the read path, tens of thousands for the write path. How do you know that they are distributed and using a certain amount of core just for the read path?
Well, we don't take that into account. It's just that we just see whether the process CPU usage is above the threshold. If it's above the threshold, the read path is disabled, or it means it stops accepting read requests.
Oh, I see. So the CPU utilization is for the entire ingester, not for
Yes, correct. Yes, correct.
Okay.
So it is quite simple.
Oh, I didn't get that. Okay, because we were going. I was going today to actually try in one of our production cluster, but a small one, if that worked, and then move to the big one because we had this problem in that the read path is taking more than half of the CPU time, and is affecting the injection. And okay, so I didn't get this at all actually. So
yeah, so it's just kind of like an idea to prevent the ingesters from dying, and then we chose by design to protect the write path. So it's more like you set like a threshold, like above this threshold, we're just going to protect the write path and ignore reads, if you see what I mean.
Oh, okay. I didn't. Yeah, it was not clear to me that.
So it was kind of motivated by incidents we had where ingesters would just like get really backlogged and the memory usage would balloon and because of heavy queries. So that's kind of like the idea.
Oh, okay. Damn it. Then
Yeah.
this might not
The
work.
write path.
It could be.
Yeah, the write path is pretty, in our experience, constant in usage. So if you see them at the stable state, that's probably how much the write path consumes. So you can put some limit and then assume that whatever that the difference is the read path, and then shed that load. But I think in Golang, figuring out what process does what is hard.
Yeah.
So we don't do that. That's why the new architecture, where the ingester is purely for queries.
Okay, I see.
Yeah, and to piggyback on that, actually, we're thinking of further splitting the ingester into two parts. One would serve queries. The other would be responsible for uploading blocks because what Dimitar said, like Golang is not really a soft real-time or any-time system, and it's just very hard to influence the scheduling and then do those measurements. By Arve. So yeah, so basically the only weapon we have in this is to split things and then just look at that one and schedule that one thing.
Okay, so your suggestion is to look at how much of the CPU time is spent on the ingestion, and then basically get a limit on.
You would look at how much CPU and memory the ingesters use in a stable state. They would still be serving some queries, but maybe half of that is the right path. You would set the limit to a bit lower than the physical limit. So if you're setting GOMAXPROCS to 10, then maybe the limiter limit would be 9. I forgot what the config option is. Same with memory. And that would, whenever the limit is reached, that would cut off all queries. It would let existing queries finish and then stop new queries.
I see. Because in our case, I don't. So we have I don't know. I think 10 CPU per ingester, but the ingester is not using the CPU. Is using 7.5. But so still around 55% is used by the query path. So there is a lot. There is still CPU to use, but it seems that it's not able to. There is some sort of bottlenecks because we reject a request in the ingesters, even if there is a if the bottleneck is not the disk, and we can't figure out yet what is the bottleneck there. So I was thinking about using the limitation on the read path because with my previous understanding now I get that it's not possible. But to say like, okay, just use less CPU for that, so at least all the rest remains for the ingestion. But which means that in this case, even setting the read limit wouldn't work at all because the CPU is not even used up to that point. We have a 10 CPU request in Kubernetes and the GOMAXPROCS set to 10, and still and we reject the request, and I don't know why.
What's the error message that you get? Sorry.
Oh, we reaches the max invite push request.
How many series are you having in those ingesters? There's a metric, and on the writes dashboard or the writes resources dashboard, you can see series per ingesters.
I think we have 5 or 6 million. Series. I might have it here. In memory series. No, this one is I'm gonna tell you.
You have right resources.
Yeah. Right resources.
I'm just asking because if you're running into that in-flight request limit, it could be related to that. At least that's my feeling, that if you distribute more series per ingester, that could play a role.
Yeah, we have 6.6 million per ingester. I think that the limit is we double it. Is like I think it's like around 60,000 requests per second. Yeah, but we have less. It's just like sometimes they just spike and they are rejected. But from many many ingesters. Some ingester sometimes, some other ingester like like 40 seconds later and so on. And the number of requests rejected are like a few thousand, maybe 10,000 a second per second across all the fleet. We have no idea why. We debug like we constantly check what's like the frame graphs to try to understand if there is something wrong. Nothing seems to be wrong, but so I the next step was the was that, which is now not a next step anymore. Well, Jira closed, I suppose, very quickly.
Yeah. And by the way, if I may ask, how many ingesters do you have? I think you.
We have. I don't know, around
Roughly
500 and something.
Yeah. Right.
Between 500 and 600.
Right.
Yeah, like after this, it's we even changed the EC2 instances to get like some faster one. We saw like a decrease in CPU utilization, so on. There were less contention resources, but still, that's not great. So I have no idea how to know this.
I assume you've looked at traces.
Slow
ingesters like Jaeger traces.
We don't have traces there because we used Jaeger in the small clusters, and but there we don't have any problem at all. It seems that the behavior drastically changed with this massive cluster compared to the other one. So it's not linear at all. It's just like something like completely different with many other components as well. And could be also, I don't know, noisy neighbors. Or, there is nothing else in those EC2 instances because we dedicate stuff just only for Grafana and that and all our microservices, but they are not really very they don't use a lot of CPU memory, IO or anything. So but it behaves very differently. So in that cluster, though, we don't have yet all the automation to gather. Like we would like to use Tempo because Jaeger doesn't scale with that many traces with one instance. So it takes time to redeploy all Grafana agent or now Alloy and stuff like that. So we don't have traces, unfortunately. And even profiling, when I get the profile, I go manually and get it. So it's not we don't have continuous profiling to. So we are lacking a lot of automation there to get all the data, historical data. So that limits us a bit with the debugging as well.
One problem we had in AWS is with network throughput on the nodes. Sometimes
it limits.
They appear weirdly, like they would appear as maybe slightly increased CPU usage, but like vastly increased latency on only some ingesters. And then we found this to be either noisy neighbors or just heavy queries that transfer a lot of data out of the ingester. And then this also affects like the whole networking on the node. And if you're using network attached disks, then that adds to that overhead. I think you should be able to find network throughput from the EC2 instance somewhere in the AWS console. I think it's also, I don't know what exporter you use for those metrics, but you can see whether like how close it is to the instance limit.
Yeah, I see that the packages are dropped in many instances. We change instance type to increase the limit, and we see still a lot of rejection. So we enable the we are trying to reduce also that problem because that surely is. We don't know if that is causing the ingestion issues, but surely it doesn't help with the debugging because you always had a doubt that okay, is it that or not? Are those like rejected packages enough to disrupt all the rest? and that is yeah, we need to fix that. So we change all the EC2 instances with new ones, but that didn't increase. So the only way that I have to reduce traffic now is to enable compression, gzip compression everywhere. But then the distributor latency is, gets higher, so we don't want that to be too high. So yeah, we are trying to see that.
There's also Snappy. Not sure if you tried it. There's gzip and stuff.
Yeah, but it's not, we already have Snappy, but it doesn't decrease as enough to basically not hit the networking limit. Because the cluster is very big, so it's there are thousands of pods, and all of them like do ingesters and the queries as well. We have like thousands of queries a second, and the traffic is just massive, and we don't know how to reduce it more. So that we tried gzip, and still we have less rejection now, but it's not enough. So no, sorry, Snappy, and now we need to move everything to gzip to decrease even more.
Thinking out loud, bigger requests would compress better. So if you send bigger requests from Prometheus or from whatever your Alloy, the agent, maybe they'll be sharded into, like, the request that's sent to the ingester would contain more series, so it compresses better. I think when you have that many ingesters, if your tenant is on no ingesters, then a request with 1,000 series gets sharded. Like each ingester gets 2 series, so it's not that efficient.
Yeah, that's a good one. We actually have something in the backlog to do that, but not for the wrong reason, but for a different reason, because we saw that the CPU utilization on the distributor gets a lot better when the requests are bigger. Because sometime in the flame graph, you can see that the CPU is used to open the package and parse it and so on, and that part is spent on opening it instead of really doing something with it. So the bigger they are, the better the CPU utilization. But
the ingester is also
mentioned it. Yeah, we should maybe do that sooner and see how that would help for this as well. So even better.
Yeah, the ingester CPU is also a bit more efficient when you send bigger requests, because it involves, like, it does syscall for more data. Like one syscall persists more data to disk, so it's a bit more efficient.
Also, in your case, I bet you have a lot of histograms. So native histograms will be something that will help you, but migrating to native histograms isn't trivial at this point. So like that's in itself a lot of work, as we know ourselves. There is, by the way, a new kind of project in Prometheus where we will be able to compress classic histograms into native histograms on scrape. So it wouldn't affect your application, your instrumentation, just the scrape. It will still produce a kind of native histogram, which is much more efficient. So that will help you. But again, on the query side, you need to rewrite your queries. Okay. And dashboards. And depending on what kind of things you're doing, the migration can be more or less complicated. Like if you can just switch to the new type and you don't want to see your data in the same dashboard, you're fine with just switching out the dashboard, then it's fairly simple. Like we have documentation in the Mimir docs on, if you go into the Mimir docs, there's visualization / native histograms, and you can see like how you need to rewrite your queries. But my guesstimate for that work in Prometheus and getting into Mimir was like 6 months, because like everything with native histograms is just complicated, because it's right in the like the base line of right in the middle on the TSDB of the Prometheus implementation. But I mean, that's coming. Also, we are working, and I hope that for the next community call, we can talk about more about an optimization that we want to do the query engine as well. That would reduce your resource utilization and speed up queries. That doesn't help you much on the write path, but overall, if you have a huge system, that will help you. So hope to speak about that in the next community call.
The streaming one?
Yeah. So if you see the PromCon presentation I did, yeah, that's the one. That now we actually started to we planned it, and it's a project internal. It's not just a hackathon anymore. It's like actually at least 2 people working on it. I don't know, maybe more. So that's coming along as well.
Sounds good. Thanks.
Yeah. All right. Any other question? Comment? Nothing. Well, thank you for coming. And,
sorry, I would have one. I thought that you were asking about that specific thing. I would have one, probably is quick. Do you have any reason why you don't set GOMAXPROCS for everything that you have in
the helm chart?
Yeah, or in well, I'm using the JSON. I'm trying to. So I see that there is nothing for the ingesters, but when we set GOMAXPROCS for the ingester, it drastically reduced the CPU usage and even the amount of rejection that we had and so on. So it seems that the scheduler was doing a much better job to actually using the CPU instead of wasting doing juggling go routines and so on. And I see that it's set for distributors and other components, but then there is a logic that I don't know where it comes from. I don't understand it. That says basically choose the max between 8 and the actual CPU request. Sometimes it's I don't know if it's multiplied by 2 or not. I don't remember. But anyway, sometimes you mentioned that 25% of the CPUs is dedicated then to, it can be used by the garbage collection. I don't know where, what the logic behind it. Why? So it shouldn't, in theory, I know that the practice is different in theory, but should in theory the runtime and all the Go routine that you spin up work better when you actually when the runtime knows exactly how many CPUs there are to be used. So and is the runtime that knows how many how to best manage the OS thread when the garbage collection needs to happen.
I don't know. Maybe the others. I only know that if you don't set it, then it's set automatically to the number of CPUs that you have, right?
Yeah, so it's automatically do however many CPUs the machine has. Detected somehow with /proc.
But that doesn't work in a container environment though, because
it just uses the number of cores on the node. Yeah. So if
we saw that the number of CPUs that we have, for example, I don't know, 32, 64, and the ingester, when the ingester has that amount of when the Go runtime thinks that there are that many cores, it works a lot worse than when we set it to the actual CPU request of the container, and that helps a lot. But that is not in your code, so I don't know if it can help to have it for the community or maybe not.
I think our thinking is that we want to allow spikes to go over the limit, and if we set the GOMAXPROCS, that would not be possible. However, we were recently discussed about setting that for distributors. The small issue is then we have autoscaling based on CPU, and if they don't go over the request, they would never autoscale. So we need to figure that out. But yeah, for this, if you want to use that, feel free to do that. I mean, on distributors, we don't think there is any problem. In our case, on ingesters, we want them to use more when they have to. Usually, not all So we have many workloads in our clusters, and not all of them need to spike CPU usage at the same time. So this works for us, but it may not work for you.
Sense. Yeah. Now I understand it. Yeah, it makes total sense. Yeah, I didn't think about the spikes and if you want that to spike.
Yeah, we haven't tried this for other components. I think we just never tried. Maybe we should, and we'll just save CPU. We have to try it and find out.
Okay. Yeah, thank you.
But like to your question, if you do try it and like it shows usable results, I think it's okay to include it in the chart or helm or JSON. Sorry. So, yeah.
Okay. Sounds good. Thank you.
All right. Anything else to this topic or to the topics before that? Other question, comment?
Native histograms rule.
Yeah, native histograms rule, but yeah. Hopefully we can have a good migration documentation as well, but I don't want to write it before we actually do our own migration and go through all the details and and just dog food it ourselves. Because
I really liked how somebody mentioned that when you have SLOs based on specific times and buckets, native histograms don't work that well because you wanted that exact boundary, and that's not easy with the native histograms. But apart from that, I think just use them everywhere.
Yeah, I'm actually working on the SLOs for ourselves to try to do them with native histograms. Yeah, I just need more JSON.NET reviewers. Never mind. All right. So thank you very much for showing up and the questions and listening. And let's close the meeting and see you next month.
Thank you very much.
Thanks a lot.
Bye-bye.
See you.
See you.